Hello students, today we will start a new chapter, that is biomolecule. Very important chapter for getting marks in CBSE examination. Direct questions generally asking in this chapter. So we know that all living beings may be animal or plants, they consist of biomolecules. These are the very essential things for all living organisms. Without these biomolecules, macromolecules, the life has no existence, we can say. So these biomolecules, it is the part of, you can say it is the part of every smaller unit, that is cell. Every cell consists of these biomolecules. If you see that structural changes, if you start from this, the first thing is biomolecules. Biomolecules combine to form organelles. Then organelles combine, present in cells. Then cell constitute tissue. Already know tissue is a combination of cell. Then tissue constitute organs. Then organs, that is your organism. Then it produces organs. Then organism means you can say that is living. These are the living things. That is, it may be animal or plant. So biomolecules constitute organelles. Organelles constitute cells. Cell constitutes tissue. Tissue constitute organs. Then organs constitute organism. So these are the different stages, different phases for the formation of living things, living organism from the biomolecules. So without biomolecules, living things is not possible. Existence of living things is not possible. That type of disease we are suffering now due to the difference in structure of this biomolecule. When biomolecule composition will be differ, or the percentage of biomolecules in our body will change, then different types of symptoms, negative effect is observed in our body. That is, we can say we are suffering different types of disease. So what are the different biomolecules are? Biomolecules are different types. These are the, you can say, these are carbohydrates. These are that proteins are biomolecules. Then nucleic acids, vitamins, enzymes, like this. So these are very highly essential biomolecules necessary for the whole living organism. So we will discuss in this chapter some important biomolecules. That is, we will start from the main biomolecule is carbohydrates. That is carbohydrates. We know carbohydrate is the important biomolecule. The carbohydrates which type of biomolecule is called carbohydrates. That we can, the definition we can define carbohydrates. These are the polyhydroxy aldehyde or ketones. Correct? These are polyhydroxy aldehyde or ketones are called carbohydrates. Means all carbohydrates contain aldehyde group or ketone group. So these are polyhydroxy aldehyde and ketones. If you see the classification of carbohydrates from these types of carbohydrate, you see classification of carbohydrates. If you see that carbohydrates may be on the basis of that number of monomer units present in the based on hydrolysis. Based on hydrolysis, it may be monosaccharides. Monosaccharides means containing a single unit. It is a single unit which cannot be hydrolyzed. It is a single unit which cannot be hydrolyzed. It is consists of a single unit which cannot be hydrolyzed again. Monosaccharides. Examples of monosaccharides is already known, that is glucose, fructose, and glucose, fructose. Then you can say galactose, like this. So these are what? Different types of monosaccharides. These all monosaccharides are called reducing sugar. These are called reducing sugar, and these are also sweet sugar, also called sweet sugar. Okay? These are called sweet sugar or reducing sugar. Reducing sugar means, already you have read in aldehyde chapter, that aldehyde and ketone, that if the compound has an aldehyde group, it reduces Tollens reagent and Fehling solution. So this property monosaccharide has, it reduces Tollens reagent and Fehling solution. That's why it's called reducing sugar. All are sweet sugar, that means sweet taste. Monosaccharides. And monosaccharides, it is two types. It may be that aldose. It may be form of aldose or ketones. Aldose means having aldehyde group. Examples are, the example is glucose. Glucose is one example of aldose. Glucose is aldose, and ketose example is fructose, having ketone. So monosaccharides, it is a single unit which cannot be hydrolyzed, and it may all are called reducing sugar or sweet sugar. These are containing carbohydrates. Okay. So second is oligosaccharides. Oligosaccharides means it is containing 2 to 10 monosaccharides on hydrolysis. When it hydrolyzes, it produces 2 to 10 number of monosaccharides. That's why this is called oligosaccharides. Examples are disaccharides, trisaccharides, tetrasaccharides, like this. These are examples. And what are the disaccharides? We'll discuss. For examples, that is maltose. Maltose contains 2 molecules of glucose on hydrolysis. Maltose gives 2 molecules of glucose, and your sucrose gives 1 molecule of glucose plus fructose. Okay, it gives glucose and fructose. And lactose produce glucose and galactose. So these are the important what? Disaccharides. These are important disaccharides. Maltose gives 2 molecules of glucose on hydrolysis. Sucrose gives glucose and fructose, and lactose gives glucose and galactose. These are all, but the important thing, all having the same molecular formula, that is C6H12O6. For all glucose, fructose, glucose, fructose, then your galactose, all having C6H12O6, only structures, arrangement is different. And this maltose here, maltose is a reducing sugar, maltose and your lactose, both maltose and lactose both are reducing sugar. It has a sweet taste, but sucrose is non-reducing. You have to remember, non-reducing, it cannot reduce these things. That means it has no free aldehyde groups. So these are some important difference between oligosaccharides, that is disaccharides, trisaccharides and tetrasaccharides. Okay. Then before that, what are the we can discuss, that is very important thing regarding the structure of that glucose. Structure of glucose, let us discuss. Structure of glucose. Glucose exists in that it is a aldohexose structure having 6 carbon and having aldehyde group. And the normal structure of glucose is like this, that is CHO, then CHOH, then COHH, then COHH, then CHOH, then CH2OH. So this is the generally that straight chain, open chain structure of this is called D glucose. D the configuration, D glucose. In the open chain structure, this is the structure, this is the arrangement of HOH group around the carbon atom. This is the Fischer formula, that is in structure of glucose written in planar form, and it is showing the optical activity nature of the glucose around the particular carbon atom. So open chain structure, if you see the optical activity chiral center, this is also one chiral center. This is also one chiral center, this is also one chiral center, and this is also one chiral center. So if you see how many chiral centers, 1, 2, 3, 4, 4 chiral centers are there in the glucose. So it has also different optical active isomer is possible. So this is the straight chain structure of glucose, and glucose has aldehyde group. I can prove that glucose has aldehyde group. Glucose has 1, 2, 3, 4, 5 OH group, and glucose has a straight chain structure. I can prove that the aldehyde group can be proved that glucose, this glucose, you can write this CHOH whole 4 and CH2OH. This glucose reacts with, we can write in different forms. Okay, we will discuss this thing. Here one, you can write the main formula here. Glucose reacts with HI, forming hexane, CH3, CH2, 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 CH3, hexane. It indicates glucose has open chain structure having 6 carbon. Then when this glucose reacts with that hydrogen cyanide, forming cyanohydrin of glucose, that is CHOH, CN, then CHOH, whole 4, CH2OH. Everything is same, only the functional group, this aldehyde group, is changing to cyanohydrin form. This is the cyanohydrin. This is called cyanohydrin. As it produces cyanohydrins, it indicates it has carbonyl group. This reaction indicates glucose has carbonyl group. This reaction indicates glucose has open chain 6-member carbon atom. Then when this glucose reacts with hydroxylamine, forming CH double bond NOH, then CHOH whole 4, then CH2OH. This is called oxime. This is that oxime of glucose, that is called glucosylgine. You can say it is a glucosylgine. Oxime form of glucose, that indicates it has also carbonyl groups. When that glucose reacts with phenylhydrazine, that C6H5NH2, when reacts with phenylhydrazine, it produces hydrazone derivative. So hydrazone structure is like this: CH double bond N NH, C6H5, then C double bond N NH, C6H5, then remaining CHOH whole 3, then CH2OH. This is the hydrazone derivative of glucose. Hydrazone. Phenylhydrazine produces phenylhydrazone derivative of glucose, indicating what? It has aldehyde groups. Then this structure indicates the open chain structure. When glucose reacts with bromine water, forming gluconic acids. That indicates glucose has aldehyde group, because bromine water is a weak oxidizing agent. It can oxidize aldehyde to acids. So this aldehyde group oxidizes to acids. So indicate it has free aldehyde group in the open chain structure. Then when it reacts with nitric acids, forming saccharic acids. This is called Sarcarigasis. This is gluconic acids, and this is called Sarcarigasis. Sarcarigasis. This reaction indicates that glucose has one aldehyde group and one end, and another end is what? Alcohol group. One end is aldehyde group, other end is what? Alcohol group. Because with bromine water produce what? Carboxylic acid indicates aldehyde group, but the terminal end is having CH2H group, there is no change. But in with nitric acid, it converts to acid, and CH2H is also converted to, because already you see the difference. Bromine water, nitric acid, then you can say that it has aldehyde group and alcohol group. This is the one important reaction, bromine water. Then when this glucose reacts with acid anhydride, it produces pentaacetate of glucose. Pentaacetate means CHO, CH3, 4, then plus CH2O, CH3. Okay, this indicates pentaacetate. This is pentaacetate of glucose. So from this reaction indicates glucose has 5 OH group, and this reaction indicates glucose has aldehyde group and acid group. This reaction indicates with bromine water it has free aldehyde group, and this reaction indicates HI. That reaction indicates glucose has open chain structure having 6 carbon. And hydrogen cyanide, hydroxylamine and phenylhydrazine reaction indicates it has carbonyl group, because aldehyde is also one carbonyl group, CO group. So these are some important structure elucidation. What type of structure glucose has, it is proved. Okay. Then we will discuss now how can you prove glucose exists in ring structure. It is the open chain structure of glucose. Now we will discuss regarding the ring structure, closed ring structure of glucose. Okay. So you finish this one, then we will next we will discuss that cyclic structure of glucose. Cyclic structure of glucose, it is observed that glucose that does not react with Gibbs base. No change. That means does not produce which pink color. Glucose does not react with Gibbs base. No pink color substance is produced. That means it does not react with Gibbs base. And glucose if you add sodium bisulfite, no reaction with glucose. Already you know, although glucose has aldehyde group, it should react with sodium bisulfite. It should react with Gibbs base. But although it has aldehyde group, already we have proved in the different open chain structure of glucose. But glucose, it is being observed that glucose does not react with Gibbs base. Glucose does not react with sodium bisulfite. No salt is formed when sodium bisulfite added to glucose solution. Third one is pentaacetate of glucose, no reaction with acetic anhydride, no reaction. That means it does not react with what? Sorry, it does not react with sodium, that is hydroxylamine. This pentaacetate of glucose, does not react with hydroxylamine with no reaction. With the hydroxylamine, no reaction. With sodium bisulfite glucose, no reaction. This reaction indicates glucose has ring structure. That glucose has ring structure. And it is being also observed that glucose when glucose is crystallized, that in alcoholic solution, that the substance produced when is crystallized, glucose is crystallized in alcoholic solution that obtain its melting point is, glucose melting point will be how much? 419. That melting point is 419 K. When glucose is crystallized in alcoholic medium, the melting point obtained is 419 K. But when it will be crystallized in water, that glucose produced melting point will be 423 K. Melting point will be 423 K. That means different types of crystals produced during what? Crystallization. When it is crystallized in alcoholic solution, its melting point is 419 K. When it will be crystallized in water, its melting point is 423 K. Different melting point observed. That means it exists in two isomeric forms. Glucose exists in two isomeric forms. It has different melting point, 419 K and 423 K. These two structures is like this. This is the ring structure of glucose. This is HOH, then HOH, then OHH, HOH, CH2OH, H. This is called alpha D glucose. This is alpha D glucose. Alpha glucose. And another structure that is OHH and HOH, that OHH, HOH, then CH2H and H. This structure is beta glucose. Here you see the difference at this point. So this is carbon number 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So at carbon number 1, difference in arrangement of HOH. So this is called anomers. This is called anomers. These are called anomers. Anomers means these are the specific type of cyclic isomeric structures differ in arrangement in particular carbon. Around one carbon they differ in arrangement in cyclic structure. These are called anomers. So alpha glucose and beta glucose are called anomers. And the ring structures having no free, just you see it has no free aldehyde groups. That's why it does not react with Skipp's base, does not react with sodium bisulfite, pentacetate of glucose, does not react with sodium, that is hydroxylamine. So this is the proof regarding the cyclic structure of glucose. That means glucose exists in cyclic structure, that is alpha glucose and beta glucose. This alpha glucose, beta glucose is converted through open chain structure. Through open chain structure, it is converted to what? A ring structure. Okay? Alpha glucose can be converted to beta glucose through open chain structure. So open chain structure also exists in particular condition. They behave like aldehyde-free aldehyde groups. So this is some important explanation regarding the ring structure of glucose. Now we will discuss this structure of glucose is called pyranose form. This is called pyranose form. Pyranose structure. Pyranose structure of glucose. This is the pyranose form and ring structure form. Then now we discuss regarding the polysaccharides. Polysaccharides. Polysaccharides have, when it contains on hydrolysis more than 10 monomer units. Monomer units. When on hydrolysis it gives more than 10 number of, that is monosaccharides on hydrolysis, these are called polysaccharides. Monosaccharides, oligosaccharides, and oligo means 2 to 10 and poly means more than 10. What are the polysaccharides then generally? And all polysaccharides, remember, these are not sweet sugar. No sweetness. It has no sweetness. Non-sweet sugar. No sweet values. And this is also that non-reducing sugar. You can say polysaccharides are non-reducing, and all that is solubility is very less, very low soluble, less soluble or insoluble in water. Polysaccharides generally almost insoluble or it may be soluble in hot water and not sweet sugar and also non-reducing sugars. These are polysaccharides. There are generally 3 types of polysaccharides. One is that is your starch. Then B is cellulose. Third one is glycogen. Okay? Then starch, if you discuss, starch is regarding starch. Starch is mainly consists of that alpha glucose, consists of alpha glucose, all alpha glucose and linear, mainly alpha glucose consists of alpha glucose. These are called starch. Water soluble, all alpha glucose, this type of glucose combined, and this alpha glucose combine one another by glycosidic linkage. For example, you can say like this is the skeleton of, like this, you can say alpha means it will be like this. Like this, okay, like this. So this is your alpha, this is also alpha form, and this linkage is called glycoside linkage. Glycoside linkage. This is called glycoside linkage between two glucose molecule. After loss of water molecule, they produce. This is called starch, alpha glucose. And here starch is generally two types. One is amylose, mainly straight chain. It is a straight chain. Only difference this is straight chain form. And another one is amylopectin, which is branch chain. And straight chain alpha glucose joined like this. In this is your, suppose this is your carbon number C1, this is carbon number C4. So C1 C4 linkage. Generally in amylose, this is C1 and C4 linkage. C1 attached to C4. C1 C4 linkage in amylose. But in amylopectin, what happens? A branch chain is produced like this between C1 and C4. C1 and C4. Again C1 and C6. These two types of linkage there. C1 C4 is a straight chain. Then C1 attached to C6 in another chains. So that's a forming amylopectin, that is branch chain. This is your straight chain. This is two types of starch. Then your cellulose. Cellulose generally beta glucose. It is a beta glucose form. Water insoluble. But this starch soluble in hot water. In hot water is soluble, and it is almost insoluble in it is not soluble in cold water and also in hot water. It is not soluble in any water. Water insoluble, cellulose, and mainly it is in beta glucose form. That cellulose not digested by human being. We cannot digest what? Which one? Cellulose. Then this is the main difference between cellulose and starch. And your glycogen mainly, these are the carbohydrates stored in the liver. These are the, we can say, these are the extra carbohydrates stored in the animal, that is animal carbohydrate. This is called glycogen. That means it is stored in the animal in the form of glycogen. If extra glucose, that extra carbohydrate that we are taking, it is stored in the form of glycogen in liver. So it supply energy. Generally when we will be in fasting, we are getting energy from glycogen stored in our body. So these are the types of carbohydrate polysaccharides. That two types, starch, cellulose and glycogen. And the starch is made of what? Alpha glucose, and cellulose is made of beta glucose. Only alpha, beta, only difference in OH group. When it will be down OH group, that is alpha. When OH group above at carbon number C1, that is called what? Beta glucose. And alpha glucose, that is the linkage C1, C4. One end C1, another end is C4, again C1, then C4, like this. C4, like this linkage occurs. But in amylopectin, what happens? In the straight chain C1, C4, again C1, C6 will be another chain. That's why it is in branch form. And cellulose only in the form of beta glucose, and it cannot be digested by the human beings. So these are very important classification of carbohydrates. So you practice your question, general diet questions, direct questions are asking in your examination. So you can appear, you can write without mistake, and it's very mark fetching chapters. Okay, thank you all.